Hello everyone, welcome to lesson 5-6, use the Pythagorean Theorem. In this lesson we will continue to apply geometric concepts to algebraic concepts to geometry. Let's look at a real world example. Parasailing. In parasailing, the tow rope is used to attach a parasailer to a boat. Refer to the diagram below for exercises 1 to 4. So we have a diagram at the very bottom here where we have a parasailer. Okay, and the parasailer is up here. We see that we have a hypotenuse coming straight to the boat, and we can measure. We have a horizontal line, which is the sea level, or just above the sea level, and then a direct vertical line to the parasailer, to the hypotenuse. Okay, so, and we have measurement being given, 72, 21, and a hypotenuse of 75. Question 1. What type of triangle is formed by the horizontal distance and the vertical height and the length of the tow rope? So what type of triangle is this? As you can see, we have two lines that are perfectly perpendicular, our horizontal line and our vertical line. So here we have a right angle. So this would be called a right angle triangle. Let's write this down. So we say it's a right angle triangle. Since the sum of the squares of the two sides is equal, or we could say the two legs is equal to the square of the third side, the hypotenuse, the triangle is a right triangle, which means 21 squared plus 72 squared equals 75 squared. And you can check this by simply squaring these numbers, finding the sum, and you'll see that it equals 75 squared. Okay? Okay. Number 2. Suppose the wind picks up and the parasailer rises to 50 feet and remains 72 feet behind the boat. Write an equation that will help you find how much tow rope the parasailer will need, how much hypotenuse. Well, we would write, we know that a squared plus b squared equals c squared. Okay? We know that we can use the distance of 72 feet behind and the 50 feet vertical rise. So we have our horizontal is 72 squared plus a rise of 50 squared is going to equal our new hypotenuse, c squared, right? When we solve this equation, 72 times 72 plus 50 times 50, we add it up, equals our new hypotenuse, and we square root the new hypotenuse, we get about 88 feet. Let's try number 4. Suppose the tow rope is 300 feet long and the parasailer is 200 feet above the water surface. Write an equation to find the horizontal distance b of the boat. So, well, we would need, again, our a squared plus b squared equals c squared, right? And we know that we have 300 feet long would be our hypotenuse, okay? Suppose the tow rope, right, is 300 feet. So we have 300 square here. Oops. Okay, 300 square there. And we know that we have 200 feet here. We're missing one of the variables, and this is 200 square. So we can solve for this. We can simply solve by isolating the a, bringing the 200 square over to this side and subtracting it, right? But remember to make sure you do the exponents for it. So 200 times 200, solve for that first, which is 40,000, and you bring it over here, and you're going to subtract it from this square root. Okay, and that should give us the answer for the equation to find the distance, the horizontal distance from the boat. So for one of our key points here, we learn how Pythagorean theorem can actually help us solve a variety of problems. It is helpful to use a diagram to determine what part of the right triangle is unknown, which means, do we have one of the legs unknown, the hypotenuse, okay? So often, for example, here, we have a building, and we know that the building is perfectly perpendicular to the ground. and that creates a 90-degree angle. If we draw a diagram, it helps us identify the area that we're looking for. So we have the height, and we have the base, or I guess you could say the length. We need to identify the hypotenuse. So you have the two legs, and we need to solve for the hypotenuse in this example. So here it is. Write an equation that can be used to find the length of the ladder. Okay, so the hypotenuse is a ladder. Then solve. Round to the nearest tenth. So we have 8.75 squared plus 18 squared equals x squared, right? And you can see that we have that here. A squared plus b squared equals c squared. We replace our variables. We solve our variables. So 8.75 times 8.75 and 18 times 18. And we get these sums. We add them up. And then we get rid of the square by doing square root, plus or minus square root. So it can be approximately 20. Approximately is 20. And we make a statement stating that since the length cannot be negative, the ladder is about 20 feet long. Okay, 20. Moving on. Number 2, we have the difference between these two airplanes. Okay, the difference between both of them. Now, it would be hard to identify how far they are, but what we can do is we can differentiate how their height, how far apart they are in terms of height, and how far apart they are horizontally. Okay, or we can directly measure how far they are apart in the most direct route, and then find the exact distance horizontally to solve for the height. So as long as we have two of them, two of the lengths, we can solve. Again, we write a squared equals b squared plus c squared, where we're looking for b squared. Okay? Once we replace our variables, we shift things around to isolate the variable. So over here, 10 times 10 equals 100. I need to bring my 100 over to this side and subtract it so that I can isolate the variable. When I do that, I get 44. 144 minus 100 would just simply be 44. So then b, we square off the 44, and it's approximately 6.6. Since the length cannot be negative, the height of the plane is about 6.6 miles. See that? 6.6 miles. Okay, so let's try it. Here's another world application where we have a stairwell. You see that? Staircase, and we know the height and how far across it is, right? But we're trying to solve the hypotenuse. And the reason we're trying to solve it is because Mr. Parsons wants to build a new banister, so a railing, right, for the staircase shown. If the rise of the stairs of a building is 5 feet and the run is 12 feet, so we have the rise and the run, what will the length of the new banister be, right? Or what will be? So we just had to solve the hypotenuse so that we know exactly how long we want our banister to be. So let's go ahead. If you know how to do this, please pause the video now and try it on your own. Pause now. So let's start with the formula, and then let's replace our variables, where my run will be my a, so 12 squared. My rise will be my 5, okay, my b squared, and then c squared. So now I will square these numbers off, and 12 times 12 is 144, and plus 5 times 5 is 25, equals c squared. And then the sum of these two numbers would be 169. Okay, 169 is c squared. I believe 13 times 13 is 169, but I can check. When I square off both numbers, square this side off to get rid of the exponent, I do get 13 equals c. So therefore, it is 13 feet for my banister, as you see up there. Okay, the Pythagorean theorem in 3 dimensions. We can use the Pythagorean theorem to find missing measures in 3-dimensional figures. And here we have our first 3-dimensional figure, okay, where we have essentially a pole right in the middle of this square, and we know that we have a 90-degree angle there, and we can measure the top to the bottom. This could be like a volleyball net pole, and this could be the rope, the length of the rope that we need to hold it up. Okay, so here we go. A 12-foot flagpole is placed in the center of a square area. To stabilize the pole, a wire will stretch from the top of the pole to each corner of the square. The flagpole is 7 feet from each corner, so it's 7 feet from each corner of the square. So it's right in the middle, 7 feet, 7 feet, 7 feet, and so on, okay? What is the length of each wire? Round to the nearest 10. So essentially, we just have to solve for one wire since it's 7 feet in every direction and the pole remains the height. So these are our legs. We have a rise of 12 and a run of 7, and we are solving for our hypotenuse. Okay? So what is the length of each wire round to the nearest 10? The triangle that was drawn here has been labeled A, B, C, right? So that we can measure our side. This is length BA, this is length CA, this is length BC, and so on. So draw a right angle triangle labeled ABC. You want to find the length of each wire, or BC, right? This is the hypotenuse of a right triangle. So use the Pythagorean theorem. So we have length AB squared plus length AC squared equals BC squared. So it's the same thing. It's A plus B equals C. We replace our variables with 7, as you see here, 7. We replace our variables with 12, as you see our height, 12. 7 times 7 is 49. 12 times 12 is 144. We add the 2 up, and we get 193. We square off, to get rid of the exponent, we square off our 193, and we get about 13.9, which for me, I would round it right to 14, because it's good to have a little bit extra. And it's a positive. It's a positive number. We cannot have a negative. Since the length cannot be negative, the length of the wire is about 13.9 feet. Okay, and now we have a cylinder here, and we're trying to find what the curve is. So we find the center point of the cone, the top of the cone, and we measure the radius, okay, the distance from the center out. And we're being given the hypotenuse, but we want to know one of the legs, right? So the top part of a circus tent is in the shape of a cone. The tent has a radius of 50. There it is. The distance from the top of the tent to the edge is 61 feet, so our hypotenuse. How tall is the top part of the tent round to the nearest? So essentially we have our A plus B equals C. So if you know how to do this, please pause, try it on your own, and then we will check. Pause now. I hope you paused the video and we're checking now. So now we have here our formula. Let's replace our variables. So I know that I have 50 squared plus b squared, because I don't have my other leg right here, don't have that, equals my hypotenuse, which is 61 squared. Okay, 50 times 50 would be just multiplying 5 times 5 is 25, and we add in the 0, and that gives us 2500 plus b squared. 61 times 61 is 3,721. Okay, now let's isolate our b by inverting the operation. Let's take this positive 25 or plus 25 and bring it to this side and make it minus 2500. So we have b squared equals 3,721 minus 2,500. And I get b squared equals 1,221. Now in order to get rid of my exponent, I have to square off this side. So I will get rid of my exponent and square root 1,221. And when I do that, I get approximately 34.9. 34.9, and I believe, yeah, it's feet. So there we go. All right, I hope you understood how we did that. You can always rewind and rewatch if you missed anything. Here's the guided practice. Please make sure you feel comfortable with this content so that we can hit the floor running when you get to class. See you in class, everyone.